Hello, everyone. In this video, we will look at the multiple choice questions for chapter 24 of the Java book. First question, what is data structure to store data in sequential order? A list is a data structure. Which of the following operations are supported by a list? Retrieve an element from this list, insert a new element to the list, delete an element from this list, find how many elements are in the list. So this is here, and find whether an element is in this list. So those are all operations supported by a list. Which of the following statements are true? My array list and my linked list are two concrete implementations of my list. True. My array list is implemented using an array. The array is dynamically created. If the capacity of the array is exceeded, create a new larger array and copy all the elements from the current array to the new array, right? My linked list is implemented using a linked structure, right? A linked structure consists of nodes. Each node is dynamically created to hold an element. All the nodes are linked together to form a list. So that's correct. In the implementation of my array list, which of the following are true? Size indicates the number of elements in the list. True. Capacity is the length of the array used to store the elements in the list. True. Capacity is always greater than or equal to the size. So here, so I think I'm going to, yeah, this should be a greater than or equal to. So, all right, so this is C is not correct. Size is reduced by 1 if an element is deleted from the list. That is true. Capacity is reduced by 1 if an element is deleted. No, this is that's not true. Next question. In the implementation of my array list, which of the following are true? Size never reduces. No, size reduced if you remove an element. Capacity never reduces. Now, see, this is that's, I think that's true if you you don't purposely trim it, so the capacity keeps going up. Inside my array list, a regular array is used to store elements, right? If the current capacity equals to size, capacity is doubled when a new element is added to my list. It's doubled. It's actually this one here, so here is it's, you can say this is doubled in the book. The implementation of this my array list, so we double the size, and it will also have +1. So I think we need to add that it's doubled and then +1 to be more precise. Here we have so this one right here, the size never reduces. So let me uncheck it, because you can reduce the size using the trim to apply the trim to a size method to make the capacity exactly the same as the size. So and this one here, the capacity is doubled. It's just more than doubled. It's double plus one. So that's so I'm going to add this a double plus one in the future. Okay. So this 24.5. Next question. In the implementation of my linked list, which of the following are true? My linked list contains all the methods defined in my list. Additionally, my linked list defines several new methods that are appropriate for processing a linked list. True. So it has get first, get last, add first, add last, remove first, remove last. All public methods in my array list are defined in my list except the trim to size method. That is true. You can use a linked list to improve efficiency for frequently adding and removing an element at the beginning of the list. That's true. You should use an array list if your application does not require frequently adding or removing an element at the beginning of a list. True. Next question. In the implementation of my linked list, which of the following are true? A node is defined as an inner class inside my linked list. So that is true. Node is defined as a static inner class inside my linked list because it does not reference any instance data fields in my linked list. Yes. Node has a property named next that links to the node after this node. That's right. Node has a property named element that stores an element. True. Next question. In the implementation of my linked list, which of the following are true? My linked list has a capacity property. No. My linked list has properties named head and tail to point to the nodes in a linked list. That's true. If a linked list is empty, head is null and tail is null. That's true. If a linked list contains one element, head points to the node and tail is not null. That's not right. Tail that next is always null. Right. Next question. My array list is more efficient than my linked list for the following operations. Insert, delete an element in the middle of the list. Not necessarily. Insert, delete an element in the beginning of, no, this is the opposite. My linked list is more efficient for this. Append an element at the end of the list. No, they're roughly the same. Retrieve an element at a given index. That's right. Using my array list is more efficient. Next question. My linked list is more efficient than my array list for the following operations. Insert, delete in the middle. No, insert, delete in the beginning. So this is the one here. All right, so now the next question. Suppose list one is my array list and list two is my linked list. Both contains 1 million double values. Analyze the following code. This is So you're going to keep removing the last one here. And this one here, you for the my linked list, this is to keep removing the first one, and this is keep removing the first one. This is my array list. This is my linked list. So this is a code B runs faster, because this is more efficient. Next question. Suppose list 1 is should be my array list, and list 2 is my linked list. Both contains 1 million double values. So here, analyze the following code. This is A. So you're going to remove, and this is remove the last one. And this is also remove the last one. So there runs as fast as B. So this A, B is by the same. All right, we're going to check all those choices now, and go and click this button. Okay, so we're going to have one problem. Let's see which one we are having. So here, and this one is my array list, the last one. Oh, okay. When you remove the last one here in the book, my linked list is the one directional linked list. So that is actually, it's going to be out of n time for this. So here, code A runs faster than code B. So that's the answer should be A. All right, we are going to stop here, and we're going to resume to look at the rest of the multiple choice questions in the next video. Goodbye.